So I'd like to continue our conversation with the object streams. So we've already discussed very briefly the object input stream. Now I'd like to flip on the inverse of that to the object output stream, because those partner very tightly together. So a quick overview is we'll look at an introduction of the object output stream. We'll look at the class declaration. We'll look at the interface for object output. We'll look at the object output methods, the interfaces methods. Then we'll look at the actual concrete constructors for the object output stream class. And then we'll look at some of the important methods that you should be aware of and some actual sample code so you can see this thing running. Okay, so quick introduction. The object output stream in Java is an output stream that writes serialized objects to a text file. It is responsible for writing objects, primitive type values, and strings to the byte stream, right? So all the stuff that we saw with the input stream, this is just the flip side of it, right? In other words, an object output stream is an output stream that serializes our primitive data values, our strings and objects to a stream. And since Java object output stream contains all the methods of the data output stream, we can perform output operations for objects in addition to the primitive type values and strings. So the data output stream enables to perform output operations for primitive type values and strings because it extends, we've already looked at that, the data output stream. So since object output stream extends data output stream, we get everything that the data output stream does, plus the ability to also write objects. So a quick look at the class declaration here is that our object output stream extends the output stream class, and it also implements the object output and the object stream constant interfaces. And so let's see here, we've already mentioned this, so let me get rid of these. And then in addition to those interfaces that are kind of unique to the object output stream, there's also the usual interfaces that get implemented with outstreams, right? Like closable, flushable, auto closable. And because this is a data output stream, we also have data output, right? So the general syntax to declare a object output stream is it's public class, it's a concrete class, right? It's a public class object output stream. It extends the output stream class and then implements the object output and the object stream constant classes, which are going to give us those new sets of methods to be able to actually read objects from our stream. So our inheritance hierarchy would look kind of like this. We have our object output stream, which is part of the IO package, which extends the output stream, which extends object. So the object output interface is in Java is an interface that extends the data output, right? And it's going to have that new method. So it supports object serialization Java because it defines this new method, write object method for serializing our data, for serializing our objects into the input streams. So we can properly encode it into bytes, so it can be preserved. So the general syntax to declare a object output interface in Java will look just like this. It's an interface, a public interface, object output, and then it extends data output, right? Which is all the primitive data types. We've seen that before, but this is going to include one new method on top of that, which is going to be the ability to support objects, which means that gives us the ability to do arrays or, our own user-defined classes, which we'll see in a moment. Okay, let's look at some of the interface methods for object output. So in addition to the methods inherited from the data output interface, object output interface also defines some useful methods. We have close. We always have close, but always remember you close whatever stream after you're done using it. We have the ability to flush. That's super important because when we're writing, after you're done writing things into the stream, you want to flush the stream to ensure it gets sent to the file and doesn't just linger. Every time you close, the close method will automatically flush for you, but you can flush in between. We have our typical write methods. So these are all the ones we inherit. This is one of the interesting ones. So the write object method, we're being passed in an object and it'll write that object into our stream. And then allow it, if our stream is attached to a file, then allow us to send that object encoded into the file. If it's if we're sending it through the network to another application, then allows the other application to get that object and be able to start using it on its own for networking capabilities. So let's look at the constructors of the ObjectOutputStream class. The ObjectOutputStream class, again, provides two constructors, just like it's in the input stream. So the first constructor is going to expect an output stream to get passed into the constructor. And what's going to happen there is it's going to wrap the object output stream around the underlying outstream, the output stream that we supply to it, which will then allow us to serialize objects and encode them into a byte stream. And of course, if any issue happens, it will throw an IO exception. So do understand there's checked exceptions there. So you either have to throw that IO exception or do a try catch block in whatever method you're doing these calls in. So our general syntax to create an object output stream would look like this. This is the more generic view here, just, standard invocation to a constructor, passing in a parameter. But an actualized example would look like this. Let's create a new file object where we give it the path as a string. And so now we have a file variable, and we're going to use a reference to that file object here and pass that to the constructor to the file output stream. So we'll essentially attach the file output stream to the file and wrap that around the file. And then we'll take that file output stream and we'll use that as a parameter to the object output stream and kind of wrap that around our file output stream. And then we'll use all of the writing into the stream using this variable here, the object output string. Again, this pattern where we're constantly wrapping is what's called the decorator pattern when we're talking about design patterns that are consistently cropping up again and again and again. Okay, let's look at the object output stream second constructor. It's the default constructor, and it's just empty, right? By not passing any stream to it, but we'll typically use the first constructor there. So the object output stream methods, most of the methods, in addition to the methods that we inherit from the output stream, there's also some methods that are useful that we should take a look at. Close, we know what close does, but it's always important that you close whatever stream after you're done using it. Here we have a default write object method. So that's used to write the non-static and non-transient fields of the current class to the stream. We have a drain method. The drain method is used to drain any buffered data in the object output stream. We have flush, which is used to flush our stream. We have put fields method here. So the put field method is used to get the object used to buffer persistent fields to be written to the stream. We have a replace object. Remember, we said that they have the ability to potentially replace an object with another object. So this method is used to replace an object with another during the serialization process. We have the ability to reset. Reset is used to reset the state of an object's already written in the stream. We have all the different write methods that we inherit. So that's normal. And since we are extending effectively the functionality of data output, then we also get all the write methods that allow us to write primitive data types. So we've seen these before, but we do have access to them from the object output stream. So we have the ability to write a Boolean into our stream, a byte primitive data type, write bytes where we can pass in a string that represents several bytes or more than one bytes, the ability to write a single character, the ability to write multiple characters by passing in a string. We can write a class descriptor. And so this method is used to write the specified class descriptor to the object output stream. Again, more primitive data types, the ability to write a double into our stream, the ability to write fields. So the write fields method is used to write the buffered fields to the stream. Again, we can more primitive data types, writing floats to the stream, writing ints, writing longs. Here is one of the big ones that we want to look at, write object. We can pass it to object, and it's used to write the specified object to our object output stream. We also have write object override. So this method is used by subclasses to override the default write object method. Again, more primitive data types, write short, the stream header. So the write stream header method is used by subclasses to append or prepend their own header to the stream. We can write unshared and we pass in an object, and that's used to write an unshared object to the object output stream. And then write UTF allows us to write a string into the object output stream. Excellent. So that's just a quick run through. And again, I'll make all of these slides available to you. And you could use these just as a reference point moving forward for this class and future classes. So as you start to author out more complicated and complex Java applications, you can use this as a handy little resource. So here's a quick sample of reading and writing the same thing we did before, student object. But in this example, we'll do the same data, but instead of, we'll improve, instead of just using a file input and output stream, we're going to use the buffered input output stream, because remember, that is more that's more performance. It's a better implementation, it's more performative in terms of its improvements. So it's always ideal whenever you're doing reading or writing, instead of writing a byte at a time, you can use this to grab a bundle of bytes at a time and read from your buffer. Okay, so these will be all the imports, and then this would be the source code, but you know what I'm going to do? We're going to go into IntelliJ. So what we're going to do is we're going to open up our object output stream tester 1 here. Let's take a look at what we're going to import. We're going to import our buffered input stream and our buffered output stream, because those are going to be a more optimized way of loading data into our application from a file. So we don't have to read a single byte and write a single byte at a time. But these themselves are wrapper classes. They require an underlying input and output stream to be wrapped around. So we're going to also import the file input stream, the file output stream, so that we can use as the underlining streams to be able to actually attach to the file. And then we'll wrap that around the buffered input stream. And then what we're going to do is we're going to import these object input streams and output streams that we will then wrap around the buffered input stream and output stream. So we're going to have an underlining, so we'll have a file, we'll wrap around the file a file input stream, and then we'll wrap around that the buffered input stream. And then what we'll do is we'll wrap around that the object input stream, and we'll do all the same thing for the output streams as well. Of course, we also have to go ahead and pull this IO exception because we have to check it. And we'll also pull the state module, so we have some kind of complex reference data type that I can go ahead and create and serialize and deserialize. So here I'm going to create a quick class, object output stream tester 1. I'm going to create my main method. I'll just throw these exceptions, the IO exception, the class not found exception. So I don't worry about handling it. I just, let those, if it happens, it happens. Then what we'll do is we'll create a new instance of that file output stream, and we're going to go ahead and use that file path. So inside of my src directory, I'm going to create an object file out1.dat. And do I have one that exists here? Let's just delete this. So we'll delete this. Okay, it's gone. Yeah, do that refactor. Okay, it does not exist anymore. Okay, so the next thing I'm going to do is I'm going to take this file output stream I created, right? And I'm going to pass that as a parameter into the constructor for my buffered output stream. So I'm going to wrap around the file output stream, the buffered output stream, and I'm going to grab a reference to that right here, right? Save that into a variable. So I can use that to wrap a object output stream around. And so I'm just for short going to call that OOS, short for object output stream. Then I'm going to use the object output stream to write all of the data that I want to go ahead and send to my my object output stream. So here I'll write a string using write UTF. Here I'll write an integer using write int. Here I'll write a double value using write double. Finally, I'm going to write an object. And so the object I'm going to write is just going to be a new instance of date, the date class. Then I'm going to flush the contents of my object output stream. I'm going to close it. I guess this is my buffered output stream. So I'm going to flush the contents of my buffer, and I'm going to flush the contents of my object. I shouldn't have to do this though, because this should handle that for me. Then the next thing I'm going to do here is I'm going to create a new file input stream, right? And I'm going to go ahead and attach to it the file that's at the same path that we just authored to, that we just wrote to. Then around the file input stream, I'm going to wrap a buffered input stream around, and I'm going to save that to a variable. Then I'm going to take that buffered input stream and I'm going to pass that into the constructor, the object input stream. I'm going to wrap an object input stream around that buffered input stream. And then once I have that, I'll have this object input stream. And then I could use that to read back all the data that's been serialized onto this file, this object file out1.dat file. So here so I'll read this. I have to read this in the order that I wrote it. So I'm going to read a string from the input stream. I'm going to read an integer from the input stream. I'm going to read another integer from the input stream. I'm going to read the double value. I'm going to read the object, which is going to be my date. I'm going to cast the date, because when I read any objects from the object stream, it's just treated as an object. Let me actually run this so we can actually see. So after I'm done reading all these data from my input stream, my object input stream, I'm going to print the values of them up in the system.out print statement. And we'll see in the console that that's my first, that's the string Ted, that's the first int 10, that's the second int 44. This is the double value 96.6, and this is that date. And then after I'm done all that, I'm going to close my streams, and that's it. Yep, that's our output. That's the explanation, but we already stepped through that. And yeah, that's all I really want to say about the object output stream.